All right, so this is U4 in vectors. This one got kind of interesting. It's writing a vector given its magnitude and direction. I haven't scanned through this one to see what's in it, so like I said, it could get interesting. And we might have to rely on my memory on this. But it could also get interesting. All right, so it says the magnitude of a vector is 6, which means it goes out 6 units, has a length of 6, and its direction angle is 0 degrees. If you have a 0 degree direction angle, you don't rotate at all, you just stay on the x-axis. 1, 2, 3, 4, 5, 6. That's where you stop. That would be what your vector looks like. Now they're wanting component form, so the x-coordinate is 6 and the y-coordinate is 0. That's really all there is to it. 6, 0. Brilliant, I'm at a 10. Here's where it could get interesting. The magnitude of a vector r is 22 and the direction angle is 270 degrees. Actually, no, it's still pretty easy. Don't have any reason to get a calculator out yet. So the angle is 270 degrees. All right, a 270-degree rotation, which I feel quite confident that you all can do. It's going to rotate 90, 180, 270 degrees positively. And this thing is going to fall 22 units to negative 22. So in component form, there is no x, and then you fell 22. 0, negative 22. Most of you guys can probably visualize this, but I'm doing the graphing so that you'll see what's actually happening. Good work, Milbrath. The angle is 0 radians. 0 radians is still no rotation. So the magnitude is 9. We'll run 9 units on the x-axis, and we will not run up. Excellent day. Here we have a 180-degree angle. I know you know what's going on, but just in case you don't, a 180-degree angle is going to rotate all the way to the negative x-axis. And this thing has a magnitude of 19, so it's going to go out 19 units when it stops. So negative 19, 0. The magnitude of a vector is 5 and its direction is 0. How many of these are they going to put in here? The magnitude is 7 and the direction angle is 90. That's straight up, isn't it? So 0, 7. Remember, oh, they went to this form, the component form, with i's and j's. Finally, something interesting. The magnitude of vector b is 7 and the direction angle is pi over 3 radians. Write the component form for b. So this is actually a good teaching problem as to where the actual formula comes from. So I'm glad this one came into place because I can show you the formula here too. All right, so first off, pi over 3 is 60 degrees. I sincerely hope you remember that. Pi over 3 is 60 degrees. They're talking about magnitude. This thing runs out 7 units, all right? The angle of rotation is 60 degrees. You could go off the side and you could do some SOHCAHTOA and stuff like that if you wanted to, but you don't have to. You're supposed to know your 30, 60, 90 theorem. I have no idea if you do or not. But opposite of the short leg 30 is the x, opposite of the 60-degree angle is the x root 3, and the hypotenuse is twice that. So if this is the 60-degree angle, this is the 30-degree angle. All right? To go from the hypotenuse to the side opposite of the 30-degree angle, I cut in half. So that'd be 7 halves or 3.5. To go from the short leg to the long leg, I introduce root 3. So 7 root 3 over 2. Now, I was making mention of a formula. All right. I'm trying to think about the best way to write this. First off, how we denote things. The magnitude of a vector v is denoted magnitude like that. It looks just like absolute value bars. That's how they denote it. So the component form can be found. The component form would be, this notation right here, ij, can be found by taking the magnitude of v and multiplying it by the sine of theta I. Sorry, about messed up. Again, running off memory here. Sine is y, isn't it? The magnitude of v times the cosine of theta I plus the sine of theta j. So let me work through this one. We've already kind of established what the answers are, and I'll work my way through it so you can see the formula works. This thing had a magnitude of 7. I'm going to multiply it by the cosine of theta, which was 60 degrees. You can use radians if you want, I, plus the sine of 60 degrees, j. Now, if you look up at your 30, 60, 90 triangle, the cosine of 60 is adjacent over hypotenuse. X over 2x is a half, right? The sine of 60, opposite over hypotenuse, ends up being root 3 over 2. So 7 parentheses, the cosine of 60 was a half, 1/2 I, plus sine of 60, root 3 over 2j. Sorry, I got that window so small so we can still see the problem. Root 3 over 2j. Then you just invoke your distributive property. 7 times a half is 7/2 I, plus 7 times root 3 over 2, 7 root 3 over 2j. I don't know what's quicker, drawing or not. On angles that I know how to work with, it doesn't make sense to use a formula, but on angles that I don't, it makes sense to use a formula. So we got 7/2 I, and then my other answer was 7 root 3 over 2j. And actually, I don't need the i's and the j's, do I? Be careful about that. That's right. We have another 60-degree angle one here. I'm going to skip that. I'm looking for something with an odd angle. Nearest hundredth. Perfect. I get to use my little formula. So I'm glad I ran across that. That was the teacher bell that just rang, which means once I finish this little video, I'm probably going to go home, because I won't be able to get away with that tomorrow. All right, so my little component form here, ij, is equal to the magnitude of the vector times the cosine of theta I plus the sine of theta j. This guy has a magnitude of 25. The angle of interest here is 36 degrees. So what I do is I put my calculator in good old degree mode. And the cosine of 36 is that funky decimal. Now you guys know enough to know that you're going to be distributing, so you multiply it by 25. 20 point, they want the nearest hundred, 20.23. I get 20.23i here, plus, time for the j's, 25 sines of 36, 14.69j. I don't like answers like that. I don't think anybody does. They did want hundredths, right? Tenth hundredths. All right, so 20.23. And I'm using the I's and J's, okay? I'm just dropping them. You don't need them when it's in component form. 20.23. So stupid ending data and forgot the next one. 14.69. Well done, Milbrath. So let's do another one of these, then we'll jump up a level, see if anything's special. All right, so the magnitude is 8. What was the angle of interest? The angle of interest is 11 degrees. So there's my I's and my J's. So I'm going to have 8 cosines of 11, nearest hundredth still. 8 cosines of 11, 7.85. And then I'm at my J's. 8 sines of 11, 8 sins of 11, 1.53. So 785 and 153. See if I can remember that. 785 and 153. 785, 1.53. That's right. So this is going to be the same. I'm going to jump up a level. Hopefully they start doing something funny here, like angles your calculator will screw up on. And this is one of them. This is one of them. All right. So I'm glad this happened. When you get to these big angles, your calculator doesn't do some of these angles quite right every time. You have to realize where you're at. This problem might kind of make me not seem like I know what I'm talking about, but I am. You're going to end up at 314 degrees rotation in quadrant 4. 314 degrees lies in quadrant 4. So your J value or Y value better be negative. And your I or your X value better be positive. Make sure that that's the case, all right? So we can probably do this by hand now. At least you probably don't need to see me writing it out. You're going to do 17 cosines of 314. That's positive 11.81. It was 17 was the magnitude. And then you're going to do, I don't know why I pulled that up. Then you're going to do 17 sines of 314 degrees. And it was negative. We got lucky. Your calculator is going to mess up on some angles. It's going to happen in quadrant 2 with the sine function. It's not going to return a negative. Or sorry, it's not going to return a positive. It's going to return a negative. So there's things you have to be careful about that, and hopefully you run into one of those. So negative 12.23. Well done. 319 is not going to be any different. So I'm going to bump up to a level. 300 degrees of rotation. Your calculator is going to do that one fine. We'll do it real quick though. I'm looking to see if there's one in here where the calculator is going to be an actual issue. That's what I'd like to see. So what do we got here? We got 13 cosines 300. That's going to be a rotation to quadrant 4. Hopefully the X value is positive. It is 6.5. Oh, they want exact simplified form, don't they? I almost glossed over that. Time for a piece of paper. I just about missed that. I was going to push buttons in a calculator. So 300 degrees of rotation. is going to leave you with a reference angle that measures 60 degrees. Now, what I know from the text is that this is 13. The short leg is half of 13, and the long leg is 13 over 2 times the root 3. Direction matters. This is negative. So that's negative 13 halves root 3. So I'm glad I ran across that. I'm glad I noticed that exact form. I would assume that they will take 6.5, but I'm not going to chance it. And this thing's in quadrant 4, so the y value has to be negative. So negative 13 root 3 over 2. If you haven't memorized your 30, 60, 90 pattern by now, it's a good time to do it. Correct. 7 pi over 6 rads. Worth doing. This is kind of an important one. I think I'm going to have you guys take this straight to 100. I hope you're able to get it. 7 pi over 6 rads should be 210 degrees. If you don't believe me, you can do 7 pi over 6. You can multiply it by 180 and then divide it by pi. And turns out I was right. So when I draw a 210 degree angle. Rotates like this. There's 30 degrees between the x-axis and the vector. That's important. The magnitude is 7. Here the 30-degree angle is opposite of the short side, so this is actually the 7 halves. Then I swing from short leg to long leg by introducing a root 3, so 7 root 3 over 2. And that should be everything I need. I just got to pay attention to signs. Negative, negative. Running left, running down. They are negative. So back 7 root 3 over 2. I bet Cora would love me to get this wrong. Not today, Cora. Not today. And then down negative 7 halves. She's probably not even going to watch the video. She'll never know. Should I go for 100? Why not? One more. All right, the magnitude is 30 and the direction angle is 4 pi over 3, which lies in quadrant 3. So I'm going to have negative x and negative y values. It's also not going to be pretty. It's going to be something with a radical, because pay attention to the text. You really need to look on that. Exact. That means you're not using technology. You're using that God-given brain of yours and a pencil and a pen. Of course, Brody, Zach, and Jaden, y'all are probably trying to do this in your head. So be it, man. So be it. I'm too tired for that stuff anymore. 4 pi over 3 is going to rotate 60 degrees into quadrant 3. Promise you it will. It'll rotate pi and then pi over 3 again. The vector had a magnitude of 30. The short leg is half of that. The long leg is that times the root 3. Direction matters. So back 15, down 15 root 3. And they have the ij notation, so no big deal. You just put the negative 15 in front of I and the negative 15 root 3 in front of j. Bravo, Milbrath. I have earned a gold effing medal. Good job. Anyways, that's ixlu4. I hope you found it exhilarating. I really do.